Okay, let's do this in the computer. Let's start Excel, and I'm going to start with the first problem in the chapter. So I'm going to bring the data from table 13.1 that is called the Chemitech. Okay, I have this information. Okay, I have the same data: 58, 64, 55, 66, 68, and so on. Okay, so the first thing that you need to do, according to the book, is to get the variances within and between. Okay, let's do the analysis of variance, the one-way analysis of variance. And in order to do that, you have to go to data. Okay, you have to have data analysis in here. If you don't have it, it's because you haven't installed the adds in for Excel. So you got the Excel options, go to adds in, go to analysis tool pack, and then you have to have analysis tool pack over here and hit OK. Okay, when you have that add in installed in the computer, you're going to find this over here, that is the data analysis. Just hit data analysis and you're going to see ANOVA single factor, ANOVA two-factor replication, ANOVA two-factor without replication. These are the three ones that we're going to use in this chapter. And this one is a single factor because it's just a treatment, one treatment, and we are dividing that treatment in different methods, A, B, and C. So this is a single factor, it's a single variable, and we are going to hit OK. It asks me for the input range. Where is my data? I'm going to give it the whole thing. This is your data from A1 to C6. And I'm going to tell the software that the first row has the labels. Okay, I'm going to establish an alpha of 0.05, and I'm going to put the ANOVA table wherever, just hitting here, just here, and hit OK. And it's going to show you all the calculations for the for doing everything that is in your book, except probably for the X bar. The rest of the things are in here. An important thing about this one-way or one-factor analysis is that you can have multiple sample size over here. Not all the sample size has to be exactly the same. It's easier when you have the same sample size, but it's not required in this procedure. Okay, so let me give you the sample means are over here, the same one that you have on table on page 510. That's the sample means, 62, 66, and 52. You have the variances, the sample variances, 27.5, 26.5, and 31 over here. And of course, I mean, they don't give you the standard deviation, but you don't need it. Then they make all the calculations, and if you see here, okay, this is your analysis of variance. Let me open this one over here. And it's going to give you two rows, the between groups and within groups. The between groups is due to the treatment or to the different levels on your factor. These are the factors. This is method ABC, and these are your factors. This is the variance due to the factors, and this is within. Within is the variance because of the error. And again, Excels give you like this. Some other software tells you treatment and tells you over here error. Okay, the important part is that you have the sum of a square. The sum of a square for the treatment is 520. And if you see over here, you are going to find that information 520, it has to be somewhere in here. Well, it is in the table. Okay, and 340 is the sum of a square because of the error. When you add these numbers, 520 and 340, it's going to give you 860. They give you the degrees of freedom. For the between groups or the treatment, it's going to be the number of factors minus 1. We have how many factors? A, B, and C, 3. Minus 1 is 2. This is why the degrees of freedom is 2. Okay, and the number of degrees of freedom in the error is 12. Why? Because we have 5 is 15. Okay, the total number of sample points are 15 points minus k. K is equal to 3 because those are the factors that we are considering. That is why it's 15 minus 3 is equal to 12. Okay, the mean square is calculated by dividing the sum of a square divided by the degrees of freedom. So the mean square of the treatment is equal to 260. Why? Because it's the 520 divided by 2. And the mean square of the error or the within group is 28.33. Why? Because it's 340 divided by 12. That's it. This is the number. So if I miss this number, I know how to calculate it because it's this number divided by this number. Now let's go to the next column. That's the F. Remember, F is equal to the mean square because of the treatment divided by the mean square because of the error, and that is the 260 divided by 28.33, and that is my F. 260 divided by 28 is 9.17. Okay, now if you go to the table and you are going to see the critical value and so on and so on, and indeed the critical value, the Excel gives you the critical value. The critical value is 3.88, considering alpha equal to 0.05, because that's the alpha that we entered when the menu came out. Okay, so my critical value is 3.88. My test value is 9. Okay, so I'm going to reject. Why? Because it's in the rejection zone. And you can see over here the p-value. And remember, when you use the p-value approach, when the p-value is less than alpha, you reject your null hypothesis, and you are going to say that the means are not equal. The means between or among the three methods are not equal. Which is different, we do not know. Okay, but we know that there are differences. So I guess that's it. I mean, the sum of the square between treatments is this one over here. I'm looking at problem number 1, and the problem 1 gives you or asks you the mean square of the treatment is over here. The mean square between the sum of a square is here. The mean square is here for the treatment. The sum of a square of the error is here. The mean square of the error is here. Compute the mean, set up the ANOVA table. This is the ANOVA table, and so on. So it's pretty easy to make the interpretation of this table. This is a very easy table. This is the sum of a square. You add them all, and you have this number. This is the degrees of freedom. For the between groups, you have 2 because we have 3 treatments minus 1. 12 is the total number of elements in your total number the total elements you have in your data set, minus the number of treatments. 15 minus 3 is 12, and then this is pretty easy.